I'm going to talk about sums and differences of rational expressions with respect to unequal denominators. In order to understand the examples I'm going to do, you need to know how to calculate least common denominators. If you do not know how to calculate least common denominators, I would suggest you watch my video on that topic. Okay? So let's start with this example. (15 over 4x squared plus 25 over 18x). So to calculate this sum, I first find the least common denominator. For this example, I'll get 36x squared. Now I need to convert each rational expression into an equivalent rational expression with a denominator of 36x squared. So I'm going to multiply the top and bottom of the first rational expression by 9. And that'll give me 135 over 36x squared. Now I'm going to multiply the top and bottom of the second rational expression by 2x. And that'll give me 50x over 36x squared. Adding the two blue rational expressions gives me 50x plus 135 all over 36x squared. Okay, now let's have you try one. (3y plus 2 over y squared minus 16 plus y minus 4 over 3y plus 2. So pause the video now and try to find this sum. Okay, I'll go ahead and work it out now. So the first step is to factor. Factoring both rational expressions, you will arrive at the two red rational expressions that I've written on the board. And now we can determine that the least common denominator is 3 times y plus 4 times y minus 4. And so we can convert the red rational expressions to the desired equivalent rational expressions. I'm going to multiply the top and bottom of the first red rational expression by 3. I'm going to multiply the top and bottom of the second rational expression by y minus 4. Now, on top, I'm going to get y minus 4 squared. Let me go ahead and expand that. So I get not y squared minus 8y plus 16. Okay, and now I can combine the fractions. Now I don't need to expand the denominator, but if anybody's interested, I'll go ahead and do it. The denominator would be 3y squared minus 3 times 16 minus 6 times 8, so minus 48. And on top we get y squared plus 9y minus 8y, so plus y, 16 plus 6, so plus 22, and I hope that is what you got, or something equivalent to that. Y squared plus y plus 22 all over 3y squared minus 48. Now I'd like you to try a sum. All right, so pause the video and try to find this, excuse me, not a sum. Now I'd like you to try a difference. So pause the video and please try to calculate this difference. All right, so I'll go ahead and work out this difference now myself. So the rational expressions are factored already, so we don't need to do that. The least common denominator is 2y minus 1 times y plus 2. So converting each rational expression into the necessary equivalent rational expression, I will get what I'm writing on the board right now. Okay, now let me check things over. So the first red rational expression, I multiply the top and bottom by y plus 2. The first black rational expression, I multiply the top and bottom by y plus 2 to get the first red rational expression. The second black rational expression, I multiply the top and bottom by 2y minus 1 to get the second red rational expression. Okay, now I'm going to expand the numerators because I need to in order to be able to find the difference of the numerators. I don't need to expand the denominator, but I'll go ahead and do that as well. So 5y squared plus 10y all over 2y squared plus 3y minus 2 minus 2y squared plus y minus 1 all over 2y squared plus 3y minus 2. Now, notice I put the second numerator in parentheses. I did that because I didn't want to accidentally think that the minus in the middle of the red rational expressions only applied to the first term, the 2y squared. You actually have to distribute that minus to the all the terms of the second numerator. Okay, that's a common source of error in these types of problems. Okay, so now subtracting the numerators, finding the difference of the numerators, I get 5y squared minus 2y squared, so 3y squared. 10y minus y, that gives 9y. And minus 1 gives plus 1. I hope you got the sign correct on that piece. And then on bottom, 2y squared plus 3y minus 2. All right, so let's do one more example. Five x minus 4 all over x squared minus 2x plus 1 minus 3x over x squared plus 4x minus 5. So pause the video and try this one, remembering that you have to be careful with the minus in the middle. Okay, so try that now, please. Okay, I'll go ahead and work it out myself. So the first thing I'm going to do is factor. And so I arrive at those two red rational expressions. Now I determine the least common denominator. For this exercise, for this problem, it'll be x minus 1 squared times x plus 5. So now I'm going to multiply the top and bottom of each rational expression by the necessary term. So the first red rational expression, I'm going to multiply the top and bottom by x plus 5. And so I get that. And then I'm going to multiply the top and bottom of the second red rational expression by x minus 1. Okay, and this one I'm not going to expand the denominator. I've said that that's not necessary, and I'm going to take advantage of the fact that that's not necessary because it's going to be a little more work than I want to do right now for this one. So let me keep the denominator the same. Let me expand the two numerators. So 5x squared plus 21x minus 20, and dealing with the minus signs with care, the second denominator is going to contribute the following: minus 3x squared plus 3x. Minus 3x squared plus 3x. Okay, now simplifying. The simplified numerator is 2x squared plus 24x minus 20 all over x minus 1 squared times x plus 5, and I hope that that is what you got as your answer.